Good day, ladies and gentlemen. Welcome back. You should be on this page by now. This is a page with a formula with polyatomic ions. And polyatomic ions, ladies and gentlemen, what are these things? Poly means what? Poly means many. More than one. Poly means one. Atomic ions is ions that are more than one element, and these are your polyatomic ions that you should get very familiar with. It's on your reference sheet here. You should already have this glued into your notebooks on the back or in the front somewhere, depending on where your teacher asks you to glue it. So you should have these. For example, acetate is C2H3O2 with that negative sign on top. Okay, C2H3O2 and that negative sign on top tells you it's -1. Okay, if it only has a sign, it means it's 1. If it's got 2, then it's like carbonate here, CO3, 2 negative. Sometimes it's 2 negative, sometimes -2. Depending on who writes it and how they write it, and then that's really one of two ways of showing that. Carbonate with a charge of -2. That just means this whole thing has the one charge, -2. And we'll go into that further in pre-AP chemistry as far as how to draw the Lewis dot for that and see that it's -2. In regular chemistry, y'all just take that, whatever it's given to you. Okay, you don't need to know the reasoning. If you want to, you can always look it up on Google. Go on the line, look it up. Okay, and then it could go up to -3 here. PO4 on the bottom. You see PO4 right here. PO4. And the charge of this whole thing is -3. Okay, it's the whole thing. It's not the O. It's not the P. There's one P connected to 4 O's, and it has a total charge of -3. Okay, so this is where your polyatomic ions are found, and you are responsible for these, be familiar with these. Okay, and so up here on this paper, I also have listed on here a handful of polyatomic ions as well, right there. Right. So how do you write the formulas for this? You treat the whole polyatomic ion as one thing. Okay. So for example, Ba is +2. Ba is +2. Ba. OH is -1. Okay. So how many OHs do you need to balance out with the two right here? So you really need 2 of them by crossing over this 2. Cross that over, put the 2 outside. And when you put the number outside, the subscripts outside, what did you notice I also do? I also put parentheses around that whole thing, because now we're saying 2 OHs. Okay? If you only do this, that's just telling me there's 2 H's and 1 O. Okay? But we want 2 OHs, 2 of this whole group. So you have to put parentheses and put that 2 on the outside. Okay? So this is wrong. So anytime you put parentheses around polyatomic ions, if you add a subscript, you'll see more of it. Okay? But put parentheses around the polyatomic ions if you add a subscript to it. If you don't, then you don't need to. Alright. So that's the formula. So the formula you write in here, Ba OH parentheses 2. To name it, ladies and gentlemen, you name the first same barium as the metal ion that never changes name. Okay, the metal ion for binary or with polyatomic, the metal ion never changes name, and polyatomic ion does not change name either for these ionic compounds. So just name it hydroxide, barium hydroxide. All right. Number 2 here, it's not numbered, but the second one, Na plus SO4 minus 2. So notice the charges are different. +1 and -2. When they're different, what do? You cross it over like that, so then the 2 drop what is it? You swap and drop. You swap it over and you drop to the bottom. So it's Na2SO4. Okay. Since this is a +1 on the Na, you don't need to cross the 1. So you cross if not balanced. Okay. Like these, it's 1 and 2 is not balanced. You cross if it's balanced, and only if it is not a 1. All right. If it's +1 or -1, you don't need to cross it. So you cross the one that's not a 1. So you cross the 2 over. So it's Na2SO4. Na2SO4 for that. And the compound name the metal. The metal is sodium. Name the polyatomic ion. SO4 is sulfate. Okay. All right, let's find one that's a little more challenging. So go through and do these. Do all of these. Look at Mg. Let's look at that almost second to last one right here. Mg 2 plus, and then C2H3O2. This is an acetate ion. This is magnesium. This is, look at the charges, +2 and -1. So we got to bring the 2 over. So bring the 2, swap and drop them. But when you do that, remember this is a polyatomic ion. You have to put parentheses around it. So Mg, oh my, I'm not going to have enough room in here. Mg C2H3O2. 2. Okay, and the name, it's magnesium, and this thing is acetate. Magnesium acetate. Yeah. And the last one here. Let's do the last one here. NH4. NH4 plus and CO3 minus 2 or 2 minus. Okay. Look at the charges. +1, -2. Are they the same? Answer is no. So you cross the one that's not a 1. Okay, so cross the 2 here, bring the 2 over, NH4 2CO3. That is your formula, NH4. Parentheses 2CO3. And you write that in, write the name. NH4 is ammonium, CO3 is carbonate. Right. Okay, complete this table. Pause the video, complete this table on top here, complete it, and then we'll move on to the bottom. The very bottom here, writing the formula. Writing the formula could be very challenging for a lot of people because it's a little different. The concept, naming it is easy. There's set rules. Writing formula is a little more difficult because you have to find the charges and you have to cross the charges, and it gets a little messy for some people. Okay, but first list the metal ion like potassium. So you write K. It's in group 1. Remember, K is in group 1. It's right there. So it's got a +1. You need to know the charge. Oxide, if it ends in IDE, that means it's an element. An ion, so in the form of an ion, okay? It's an element, and the element is oxygen. So oxygen, right here, periodic table, group 16, so it's got a -2. And now you look at the charges and you cross them. It's K2O. Bring the 2 down, swap and drop it. So it's K2O. Follow? Pretty cool. And so try number 2 real quick here. Iron 2. Iron is a transition metal, so those are nice because it gives you that Roman numeral that gives you its +2. Nitride, again, it ends in IDE. It's an element. Nitride comes from nitrogen. So this is element ion. Okay, so it's called nitrogen, and it's in group 15, so it's -3 right here. Nitrogen, it's -3. So these charges are different. So what do? You cross 2 this way and 3 that way, and that's how you get the formula Fe3N2. I didn't explain why this works yet, but look at the charges. This is 2 and +2 and 3. So if the total charge, 2 of nitrogen will give you -6, right? Each one's negative 3. 3 of positive 2 will give you positive 6. And notice they balance down to 0. That's the whole goal of writing these formulas, so they balance each other out. You have to balance out to 0. That's why we cross it, and it works that way. Okay? And that's number 2. So let's go down to number 5. Number 5 here. Calcium. Get the charge for calcium, the oxidation number for calcium, which is in group 2. So it's plus 2. Then phosphate, no, it ends in ate or ite. That is a polyatomic ion. And you have to look at the chart for your polyatomic ion. You're not expected to memorize them. You're not expected to memorize the charge yet. Polyatomic ion is negative 3. And now you cross them. Okay, they're different charges. Cross them. 3 comes over here. 2 comes over there. And if I put a number next to a polyatomic ion, what do I need to do? Put parentheses. Correct. So Ca3PO4 2. Ca3PO4 2. That is the formula for number 5. You will complete all this side. Okay. Pause it, complete it, and then go on to the next page. Get to the next side. Right. This side you're naming it. Naming is a lot easier. So what you need to pay attention to is transition metals. Pay attention to transition metals. You have to use the Roman numerals. Remember, it's 1, 2, 3. The charges. You have to use the charges to indicate the charge, their oxidation number. Like here, iron Fe2S, number 16. Right? So number 16, Fe2S3. So how do I know the charge of iron? Okay, it's not this 2. Okay, it is not that 2. So remember we crossed the charge down to the other one. So now we cross it back up to get the charge. So you cross subscripts back up to get the charge. So this iron is plus 3. So you write iron 3, sulfur becomes sulfide. Okay? If an element, you change the ending, sulfide. Cool. What else? So you should be able to do all this on your own now. Number 20. Look at that. That's a special one. Number 20. CuO. Notice copper is a transition metal. Okay? Copper is a transition metal. And so, what's the charge? There's no subscript, so you can't cross anything. But we know that oxygen is negative 2. So in order to balance this whole charge out to 0 charge, what must copper be? Copper must be plus 2. So this one is copper 2 oxide. Okay. The other ones without transition metals, you just name it normally. Okay, like the first one here. Mg is magnesium. That's not a transition metal, so you just write magnesium. SO4, that's not an element. That's a polyatomic ion. So go back to that list. Here's the polyatomic ion list. Find the polyatomic ion list. Here it is, SO4. Find SO4. SO4 is sulfate. So magnesium sulfate. Practice, practice, practice. Remember, ladies and gentlemen, practice makes better. So what you do is practice, complete this page, and that's it for this video. Or actually, no. After you finish that page, you go on and complete this next page here. Your teacher will have the answer key to this, or it will be posted. Either one, ask your teacher, and you should be just fine.